Writing assertions is not always easy. You need to be prepared for a number of iterations until your pre- and post-conditions are accurate. Your typical chain of tools looks like this. Here you do have test inputs, either randomly generated or systematically generated, or coming from users or coming from production. These test inputs are being checked by preconditions, and the results of the computation will be checked by post-conditions. Now, as it comes to preconditions and post-conditions, you can be either too permissive or you can be too strict. If you are too permissive with your preconditions, this means that inputs which shouldn't go into the function and then result in arbitrary behavior. If you are too strict with the preconditions, this means that valid inputs will result in failing preconditions. The same also applies for post-conditions. If you are too permissive with your post-conditions, this means that you will not catch a number of bugs. If you are too strict, however, then you will catch bugs where there are no bugs. The key is to come up with the right balance between these two. You don't want to be too permissive, you don't want to be too strict. In theory, you'd like to have preconditions and postconditions that capture exactly what the program is doing. However, in practice, you will find that while writing preconditions is typically easy, writing postconditions for regular functions can be very hard, and therefore it is very common for postconditions only to check a part of the actual state. That is, you have postconditions that are simple but a bit too permissive, that is, they miss errors, whereas for preconditions it's frequently feasible to come up with the right level of precision. Why is it that postconditions are so complex? To give you a simple example of why writing correct postconditions is not easy at all, let me give you a very simple example. Let's assume we do have a sorting function. The precondition for a sorting function is simple. Basically, we simply assume that X is a list. Well, we could put up an appropriate assertion here, but the precondition is to accept essentially anything. For the postcondition, we have to make sure two things. First, we assume that the list Y that we will return actually is sorted. But we also need to make sure that the list we return is a permutation of our input list. So let's go and check whether a list is sorted. We iterate over the elements of Y, and if one element is greater than its successor, we return false. Otherwise, we return true. So what you see here is that in order to check the post condition, we needed to come up with another function, which actually now should again be checked against what? The property that is sorted checks here is essentially already described in here, meaning that any assertion you could have here would be just the same as anything you have in here. So you simply have to believe that this is true. Well, I didn't believe that. I actually ran a number of tests, so I'm pretty confident that this works. Now, this is just is sorted. You also have to come up with is permutation, which is also something you'd have to define. Helper functions like is sorted or is permutation will probably be helpful later in the future because you may be able to reuse them for other purposes. They may even become part of a library.